So we've been talking about logarithms, and we talked about the power property, which pulls an exponent down, and we talked about the change of base property. Both of those are huge steps to allow us to solve logs. There's two more fundamental properties of logs, and these come directly from the rules of exponents. So let's take a look at the exponents for a quick sec. X to the m times x to the n, I can simplify that to x to the m plus n. And so here we have a product, and we can add the exponents up as long as the base is the same. And it's also x to the m divided by x to the n equals x to the m minus n. Again, same idea. In this case, we have a quotient, we have a division, quotient, and we subtract the exponents. Logs follow that, and we can actually derive those. I'm not going to, but the same idea. Something's called the product rule. And it says log of m times n, squeaky chalk, equals log of m plus log of n. So the argument is multiplied, and out here we expanded it, m plus n. We can do the same thing with the quotient. It's called a quotient rule. Log of m over n. That's my dog drinking her water in the background. She just finished her dinner. Yeah, that's Zoe. Equals log of m minus log of n. So, division, subtraction, multiplication, addition. Okay? So let's see how we can use these. Oh, I need to erase them. My board's not big enough. So let's try this problem out. Log base 3 of x plus 2 minus log base 3 of x equals 2. Now, the bases are the same, so we can go ahead, because it's a subtraction, we can divide those. This is the quotient rule. We use the quotient rule. Okay, so we're going to use the quotient rule. Here, it's in this form. I'm going to put it back in that form. So, log base 3 of x plus 2 over x equals 2. I can go ahead and say 3 squared equals argument. So 3 squared equals x plus 2 over x. Solve for x, so 9 equals x plus 2 over x. Okay, so x is a quarter. And we started with this kind of large thing up here, used the quotient rule, and from the quotient rule we were able to get it into arithmetic, solve for down here. Okay? Let's do another one. I think I got enough room. How about log base 2 of x plus log base 2 of x minus 3 equals 2. It's addition, so this time I'm going to use the product rule. Okay, use the product rule. These guys are added together. Let me emphasize it's that way. These guys are added together, and I'm going to go ahead and multiply them. By the way, we just have two terms. If I had multiple terms, plus this, plus this, plus this, plus this, or throw a minus in there if you want, I can mix and match these. I can do them once and then do them again. And just keep daisy chaining them. So, okay, added, we're going to multiply them, so log base 2 of x times x minus 3 equals 2. To that guy, back to this one. Hey, our good old friend the quadratic comes back to us. X squared minus 3x minus 4. I'm going to solve this out. This is going to be 4, 1, I want negative 3, so negative 4 plus 1, x, negative 4x, let's check our work, x squared plus x minus 4x minus 4, x squared minus 3x minus 4, it's good, and then my factors, those guys, so that. Zero product property, x equals negative 1 and x equals 4. Okay. So, take a look at these answers. If I put negative 1 into this equation right here, I would have log base 2 of negative 1 plus log base 2 of negative 4. That doesn't work. One of the things we haven't really talked about, I'm just going to kind of just barely touch, is the log function looks like this. Where it crosses at 1, and it's never negative. Logs are never ever negative. They're not defined over here. So this answer cannot work. So my answer has to be 4.